Today we're going to be going over the Java solution for Leetcode 94, binary tree in-order traversal. Given the root of a binary tree, return the in-order traversal of its nodes values. So here we're just going to be given a binary tree and we're going to perform the in-order traversal of it and add the values of the nodes into our list as we're going through it, and then that's what we're returning. So for example 1 right here, we have this sort of binary tree. And here we're gonna return the output, which is gonna be 1, 3, and 2, as like if we're going through the in-order traversal of it, that's what we would get. I got another example here as well. So with this binary tree specifically, the way in-order traversal works is that we're gonna keep looking onto the left, and then after we've reached the end of all of it, we're gonna add that left root, and then we're gonna add the root above it, and now we're gonna look for the right. So for example, I'm gonna add our list of elements. So this is what we would be outputting. We have this one right here. We are looking at it. We can see that we can go to the left, so we're gonna go to the left. And now with this 2, we can also see that we can go to the left again. So we're gonna go to this 4. And now with this 4, we can't go to the left, so we're going to add the 4. And then after that, we're going to try to see if we could go to the right. We cannot. So now we move back up to a 2. Now we have to add the 2 since we've checked all of its lefts. And now that we have the 2 right here, we're going to look at to the right and we see the 5. Now we're going to look for the left of the 5. That doesn't exist, so we add the 5 instead. And now we're going to look for the right of the 5. It doesn't exist, so now we go back up to the 1. And now since we checked all of its left of the 1, we're going to now finally add that 1, and now we're going to look for the right. With this 3 right here, we're going to call onto its left. We see there's a 6, we're going to see its left, and it's a null. So now we go back and we add the 6, and now we're going to look for its right. There's nothing there, so that means we could go back all the way up to the 3. And since we've checked all of the lefts of the 3, we can add the 3. And then we could look for the right of it. There nothing exists, so this would be our final integer list that we would be returning. So hopefully that was a good explanation. But basically, for in-order traversal, there's 2 ways of approaching it. We could either go for a recursive or an iterative solution. With recursive solutions, it's usually easier to implement, and then iterative solutions, they are usually more efficient in general. So we're going to be doing both of them, starting with the recursive solution. So with the recursive solution, we're going to have a helper method that we're going to recursively call to look for the left, and then keep looking for the left, and then right, and then node, and yada yada yada. So first, we're going to initialize our list. So we're going to have list integer. I'll just call it list, and that's going to equal to a new array list. And now I'm going to call the helper, and the helper is going to take in the root and the list, and then after the helper has recursively called itself over and over, we've added stuff to the list, we can return the list at the very end. So now let's actually go on and implement our method, our helper method. So public void helper is going to take in a tree node root, and it's going to take in list of integers, this list. So what do we do with the helper method? Well, first, we're going to see if root is not equal to null. So this means the root does exist, so we're going to check on its left. So we're going to call helper root.left, and we're also going to put in the list. So we're going to check on all its left, and then if the left isn't a null, it's going to keep looking on the left and over until we have a null on the left, in which case we could go up and then add that element to our list. So we can do list.add root.value. And then after that, we've added that, we're going to now look at to the right. So we're going to do helper root.right and then the list. So let me see if it works. There's no compiling errors. Great, so it does work. Let me actually go on to explain how this would work. So first, we have the whole list and everything like that. We're going to put in this root at the start. We can see that it is not equal to null, so then this helper is going to now call the left of that. So we can see that it's not null as well, and we can go to the left, so we're going to go to the left, and it also sees it's not null, so it's going to call even more to the left, but in that one it does see it's null. So going back to the 4, it's going to add the 4, and then it is going to look for the right, and it doesn't see anything to the right, so this whole iteration of the 4 is done. So we move up to the 2. So now the 2 has called all of the lefts. The whole left side is basically finished. So now we can add the 2 finally, and then we could go look at the right. And then we see the right, it has a 5, it's gonna call the left, and then it has a null, so then we add the 5 with the list.add, and then we're gonna look to the right of it, and we're not gonna find anything. So then we go all the way back up. Now this whole 2 section is done. Since we have looked through the left, we have added all the elements, we have added the 2, and we've added all of the roots on the right as well. So we go back to the 1, and here we have finally finished all of the left side of the 1. So now we could finally add the 1, and now we're gonna look for the right. So now we're at the 3. The 3 is gonna look for the left of it, and it sees a 6. If that's gonna look for the left of it, it's gonna be null. So that helper is done for the 6, and now we can add the 6. Now we can look for the right. There's nothing there, so now we're done the whole left side of the 3. So we could finally add the 3 to our list, and then we're gonna look to the right. We don't see anything, and after that we are basically done. We have traversed through everything. So that's how it works. Let's submit it, and there we go. So that was the recursive solution. Now I'm gonna go over the iterative solution. So actually I'm gonna go back. I'm still gonna keep the list, but with the iterative solution, I will have a stack instead. I'll have a stack along with it, and the stack's actually gonna be a tree node. I'm just gonna take a tree node. So stack equals new stack, and now also I am also gonna keep track of a tree node current, and that's gonna equal the root, that root of it. So now while current is not equal to null, or the stack isn't empty, so dot stack is empty, so it's not empty. So while it's not empty and while the current isn't equal to null, we're going to loop through it one more time. So while current is not equal to null, so here with this is that if we go back to the example right here, what we have is that with this 1, we're going to now look to the left of it. We're going to actually add that. We're going to do stack.push current. We're going to push that current, and now current is going to equal current dot left. So now this current, so what we did is that we pushed in the 1 to our stack, and now our current root right here is going to equal this left one right here, and we see that still will trigger the while loop since the current isn't null. So then we're going to push 2 to our stack, and now we're going to go down to the 4, and now we're going to push the 4 to our stack. Then we're going to go down, and we say the current value is null. So what we can do is that after we break through this loop, we have a null value. We can do current is going to equal stack dot pull or stack dot pop. I meant stack dot pop. And what we can do is that we could add that to our list. So current dot val, and now current is going to equal current dot right. So here what we have is that we have looked through the left of the 4. We see it's null, so we go back. Now we're going to pop it. So the last element we added was a 4, so we can pop that and then add that to our list. And now we're going to have current be the right one. So it's going to trigger this while loop still. It's going to see the right, and that right is also null. So we're going to go back and we're going to pop the last element we added, which we've already popped the 4. So the last element after that was the 2. So now we've added the 2 to our list, and now that's going to call to the right here. So now it's going to look at the 5. It's not empty. And now we're going to push that onto the stack, and now we're going to look to the left of that. We see there is nothing there. It's null, so we're going to pop the last element we added, which was the 5, and add that to our list. and now we're going to call the right of it. We see there's nothing there, so now we're going to pop it again, and the last element that was added, so we've popped the 4, we've popped the 2, we've popped the 5, so the last element actually is all the way up here at the 1. So now you can see how like we would go look at the 3 and then the 6, and then eventually we would have everything there. So when everything is done, we can then return our list at the very end. So now let's see if there's a compiling error. Okay, nope, no there isn't. So now we could submit it, and there we go. So that was both the recursive and iterative solutions of binary tree in order traversal.